Good day, learners. In this video, we are looking at question 4 of the November 2017 question paper. We are currently busy with functions questions in all of the question papers. And this one, nice parabola question, which actually contains a little bit of calculus here. So for those of you who have not really looked at calculus yet, that's fine. Don't stress too much about question 4.1 then. Right, so question 4 says given the function fx is minus ax squared plus bx plus 6, the gradient of the tangent to the graph of f at the point negative 1, 7 over 2 is 3. Show that a is a half and b is 2. Okay, right, so in calculus we learn that the derivative is equal to the gradient. Okay, this is what we learn in calculus, and those of you that have not done this yet, don't stress about it. You can just skip ahead a little bit to 4.2, or I mean, you can watch it because we're going to do calculus after this anyways. Okay, so the derivative I get, let me just quickly briefly just mention that ax to the power of n, the derivative of a term I get by multiplying this n in front, the derivative. It's the short rule to finding the derivative. I multiply the n in front with the a, and then I subtract 1 from the x for every single term. This is what I'm going to do. So if my function here in terms of x is minus ax squared plus bx plus 6, I'm going to take this derivative. For every term, this is what I do. Multiply the exponent and subtract 1 from the exponent. So, multiply the exponent in front. 2 times negative a is going to give me negative 2a. And subtract 1 from the exponent, making it a 1. This exponent there is 1. Right? So, multiply the exponent in front. 1 times b is just b. Subtract 1 from the exponent is going to make that a 0. And this exponent there of the x is 0. Since there's no x, it's x to the power of 0, right? So multiply the exponent in front. 6 times 0 is 0. And subtract 1 from the exponent, making it that, but I mean 0 is going to fall away. Right, so let's just simplify this a little bit. So minus 2ax to the power of 1 is just x, and x to the power of 0 is 1, so b times 1 is just b. There's my derivative. Alright, and the derivative is the gradient. So they tell me the gradient is 3. That's the derivative, right? So the derivative is going to be 3 at the point where minus 1, 7 over 2. So at the point where x is negative 1, right? So I'm going to make this x negative 1. And then this should hopefully help me a little bit. The gradient at the point O. This produces an equation. Let me just simplify. Negative 2 times negative 1 is positive 2a plus b. This produces an equation in terms of a and b. I'm going to need another equation. So this point, negative 1, 7 over 2, lies on the graph of f. So I can substitute that in f as well. So this part I have, this is equation 1. I'm just going to mark it because I'm going to need it. And then fx is minus ax squared plus bx plus 6, where I have the point negative 1, 7 over 2 that lies on the graph of f. So I can substitute that in there. The y is 7 over 2 and the x is negative 1. X is negative 1. And then if I simplify this a little bit, 7 over 2, this is actually 1. So that's just negative a minus b plus 6. And, well, I don't like working with fractions. So I'm actually also just going to multiply with a 2 throughout 2. Making that 2b and 2 making that 12, right? Just because it's not necessary. I don't like working with fractions. Okay, and here's my second equation. And now if I do simultaneous equations with this, it's going to give me the values of a and b, which I need to show is a half and 2. Right, so let me just write these two equations here. 2a plus b, and 7 is equal to minus 2a minus 2b plus 12. Okay, so I'm going to get, I assume I'm going to get 2a because I have a 2a there. It's not even necessary to actually make this a and then multiply the a again with 2, which there is a 2a already. So 2a is 3 minus b, right? Which means I can replace that 2a with 3 minus b, right? Just to make it less complicated for myself. I mean, you can divide with 2 here and then substitute and then multiply the 2. It's just unnecessary. So since there's a 2a and a 2a, I just substitute 2a. Okay, so I have 7 minus 3 plus b minus 2b plus 12. B minus 2b is minus b. Minus 3 plus 12 is 9 and 7. And I'm going to take the b to this side. And 9 minus 7 is 2. So I have b is 2, meaning that 2a is 1. So a is a half. And I wanted to show that a is a half, b is 2. That's what I did. Okay, great. Calculate the x-intercepts of f. Alright, so for those of you that are now joining us with skipped 4.1, if that's fine, if the a is a half and the b is 2, this equation now looks like this. The a is a half, the b is 2, so the equation that they gave me now looks like this. Now calculate the x-intercepts. To get x-intercepts, I'm going to make y 0. So in this equation, which is equal to y, I'm going to make that equal to 0. Right. I don't like working with fractions, and the negative there in front is a bad idea. So I'm just going to multiply throughout with negative 2 to get rid of this. So times negative 2 is going to make this 1 positive. Times negative 2 is going to make that 4. Times negative is going to make that 12. Negative 2, and then I can factorize. Or you can just use the quadratic formula in this format. So I'm going to quickly factorize this guy. Minus 6 plus 2 minus 12. Okay, so x is 6 or x is negative 2. Right, they want me to calculate the x-intercepts. Let me, for safety, just write the x-intercepts there as sets of coordinates. There we go. Okay, so question 4.3, they say, calculate the coordinates of the turning point of f. Now, in the previous video, I discussed that you can either take this equation and complete the square, writing it in PQ form, and then you can just read the turning point off, or there's a quick way which you can use, that p is negative b, which is 2, over 2a, which is negative a half. And then, I mean, you can use your calculator for this if you wish, but that's 2. So the p value is 2. And then the q value I get by taking this equation and substituting the p in there. So I have minus a half p squared plus 2p plus 6. P is 2. And then you can use your calculator there again. Minus a half, 2 squared is 4, plus 4 plus 6 is 8. Okay, right, so Q is 8. 4.3, they want the coordinates of the turning point. So the turning point is the point 2, 8. There we go. 4.4. Sketch the graph. Clearly indicate all intercepts with the axis and the turning point. They've actually helped me so far a lot here. So I already have x x-intercepts at -2 to 4, 6. I have x-intercepts at -2 and 6. I have a turning point at 2, 8 there. Let's just lift it up a little bit higher. Sorry about that. Okay, so turning point at 2, 8. And then obviously this is a parabola because it's a quadratic equation. So I draw a parabola through those points. And then I also need the y-intercept, which if I make x 0 in this equation, it's 0, 0, and 6. So I can somewhere see, I can somewhere see that that is 6. So I have my x-intercepts, I have my turning point on the graph, I have my y-intercept. If you do need to do a calculation, but I mean it's not a really tough calculation, and there's my sketch. 4.5 says use the graph to determine the values of x for which fx is bigger than 0, bigger than 6. Fx is bigger than 6. Okay, so for that part, the fx, there's 6, right? So where is fx bigger than 6? Above 6 is that part there. So from there to there, I need that point. Now, just by symmetry, actually, since that is the point 2, from 0 to 2, that's 2 units, right? So 2 units further will be 4, 6. Right, this is the point 0, 6. That there is the point 2, 6. Right, all on the same level where y is 6. 0, 6, 2, 6, 4, 6, because I'm moving by symmetry 2 units forward, again 2 units forward. So this, they want to know that the area where this graph is bigger than 6 is from 0 to 4. Right, so x lies between 0 and 4. Okay, the values of x for which fx is bigger than 6 from 0 to 4. Then they say sketch the graph of gx, which is minus x minus 1, on the same set of axes. Clearly indicate all intercepts with the axis. Minus x minus 1. Minus x, for those of you that really understand straight lines, minus x is a 45 degree there. Minus 1 is going to move it down 1 unit, placing it there at minus 1, minus 1. For those of you that's not sure what happened here exactly, now since I have two graphs, I must just label them. This is F, this is G. You are more than welcome to just go with y is minus x minus 1. Go with the x-intercept, making y 0. Is negative 1, so I have that. X is negative 1. And the y-intercept making x 0 is going to be negative 1. There's my y-intercept at negative 1, and then draw a line through that. Okay, so this is question 4.6, which I've done on the graph, and then on graph. So 4.7 is write down the values of x for which fx times gx is smaller or equal to 0. So the two functions, smaller than is negative, below 0, negative. So we've had something similar in the 2016 paper. Smaller than 0 means I'm looking for a negative result, and this is something multiplied that should give me a negative. Now I know a positive times a negative gives me negative, and also a negative times a positive. So this translates this here translates to one graph must be positive and the other one negative, or the one must be negative and the other one positive at the same time. I don't want both positive or both negative. I want one positive and one negative. So that means one above and one below the x-axis at the same time. So if I look at this graph here, there one is above and one is below. One is above, one below, and then at the point -2. So from negative infinity, I have this great result that one is above and one is below up until that point, right? Where at -2, where this one goes above, then both of them is above. For a little bit, there in that section, that's not good. Both of them is above, but just then a little bit further, at -1, this one goes below. Then one is above and one is below, one is above, one is below, up until that point. So from there, one is above, one is below, up until that point where this one goes below again, then both is below, and that's not relevant for me. So I want from -infinity to -2, and then again from -1 to 6, right, is where one is above and one is below. In that section, both is above. Then from -1, one is above, one is below, and then at 6, then both is below. So from -infinity up until 2, and then again from -1, -2, -infinity to -2, and then again from -1 to 6. Right, and I just want to check -infinity or infinity I cannot include, but I just want to check whether I should include those points. That purely depends on whether they included the 0 points here or not. So since they asked smaller equal, then I will also include my 0 points. If they did not put the equal, then I don't include my 0 points. Okay, and that's question 4. I hope you really found some value from this, and I've brought you some clarity on this if there was any questions. And I'll see you again in the next video, where we're going to look at question 5 from November 2017.